Alright class, in this session we are going to continue the topic permutation and combination. In the last class we had discussed about factorial sign, right? Now, in today's class we are going to discuss about some of the important facts of arrangements, right? Now what do you mean by that? Now let's suppose I have 4 cards, 1, 2, 3, 4, right? And the alphabets on that cards are L, W, F, O. Alright, so if I am going to ask it how many arrangements are there that I can make if I use each card once, that means that is an arrangement, that is the first arrangement, L, W, F, O, that is the first arrangement, or I can say that it's L, W, O, F, that is the second arrangement. I can say that W, L, F, O, third arrangement, W, O, L, F, fourth arrangement, and there are many arrangements we can do with these 4 letters. Alright. So the shortest method, let's suppose there are 4 letters. If we have 11 characters, then how we are going to find out the proper arrangements, number of arrangements, right? So the answer for this part, if you have 4 letters, that means the answer will be 4 factorial. It is 4 into 3 into 2 into 1, which is equal to 24. So there are 24 possible ways in which we can shuffle the letters L, W, F, O. And I have shown you only 4 examples here. That means there are 24 possible ways to write down the characters W, F, L, O. So these arrangements we are going to discuss in this session, and these arrangements are very important because you will see questions from this concept in your past paper as well. Further, let's suppose that we have some students, right? We have 3 boys and we have 4 girls. I need to arrange them in a row, right? I need to arrange them in a row. So that means they need to stand in such a way. 1, 2, 3, 4, 5, 6, 7, right? We have total 7 students, in which 3 are boys and 4 are girls, right? Now, my question is, in fact, let me do a little bit changes here. Let's suppose I'm saying that it's 2 boys and 5 girls. Now my question is, if I am going to arrange them and there is no restriction, any students can be stand in any order, so how many possible ways are there that these 7 students can arrange themselves in a row? You can observe that we have 7 students. That means the number of possible arrangements is 7 factorial. You can find out the 7 factorial directly from your calculator. In your calculator you have an exclamation mark symbol, that is factorial. So there are 5040 possible arrangements in this. These 7 students can be arranged in a single row. Alright, so that is a very simple and very normal question you will see in the past paper. Now the complicated part. If I am saying that, that is the second part. If I am saying that I need to arrange these 7 students in a row, fair enough, but my condition is 2 boys must be together. Now that is a condition part. It means that if I am going to say that that is my first boy, so that will be my second boy. The 2 boys must be arranged or must be stand together, that is the condition. And for the girls there is no restriction. Alright. Now how you are going to solve this question? If we talk about girls, so there is no restriction on girls, which is 5 factorial, right? If you talk about the boys inside, so let's suppose it's boy 1 and it's boy 2, right? So they can swap their places as well. Let's suppose boy 1, boy 2, or you can say it's boy 2, boy 1. So the possible arrangement they can shuffle is 2 factorial. Alright, and now the placement of these 2 boys that they can stand at this spot, 1, 2, 3, 4, 5. So the placement of these 2 boys can be shuffled, right? But the condition is these 2 boys must be stand together. So the final answer, it will be 2 factorial into 5 factorial, and now the placement. For placement, how many boxes we have? We have these two boys will be stand together, so we are going to count them as 1. So it's 1, 2, 3, 4, 5, 6 into 6. Alright, and you can solve it, so you will get the final answer. Now, if you are confused about the 6, why we are using 6 here, so let me give you an example. 1, 2, 3, 4, 5, 6, 7. Listen beta. These two boys can be stand here, right? These two boys can be stand here. These two boys can be stand here. These two boys can stand here, here, and here. So there are 6 places at which these two boys can stand. Alright, so that is why we are multiplying with a 6, because the placement of boys, they can be varied, but they must be stand together. So that is a short description of the exercise that we are going to start in this session, and this session is very important. So you need to build the concept first, right? That is why I have explained you, and now we are going to continue with the exercise question. Alright, now moving on towards the exercise 10.2. It's question number 1. It says find the number of different arrangements for people sitting in a row on a bench. Now that is the same example we had discussed, right? It's 4 people, they are sitting in a row on a bench. So how many possible arrangements are there? Give it a try first. Give it a try for both of the parts A and B, and you have a time of 2 minutes. So start. Alright. For the first part, since it's 4 people, they are sitting in a row, it's very simple. 4 factorial, which you can say that 4 into 3 into 2 into 1, which leads to 24. That is your first part answer. For next part, you have 7 different books on a shelf. Again, a simple question. All you need to do is find out 7 factorial, which is equals to 5040. That means if you have 7 books and you need to place them on a shelf, so the possible number of arrangements we have is 5040. Alright? I hope that it is clear to you. Moving on to the next one. Alright. It says find the number of different arrangements of letter in each of the following words: tiger, Olympics, and paintbrush. For all 3 parts, you have a time of 3 minutes, not 3 factorial, 3 minutes, so start. Alright, for the first part, in which it's tiger, you can count the number of letters. It's 5 letters, so the first part, it's 5 factorial, which is equals to 120. So there are 120 possible ways in which you can arrange the letters TIGER. For second part, Olympics. How many letters? 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 factorial, and you can find out the value for 8 factorial. It's equals to 40320. For C part, it says paintbrush. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for C parts, it's 10 factorial. And the value for 10 factorial is 3628800. That is your question number 2 answer. I hope that you are getting the concept that how to find the number of arrangements if you are arranging a letter, number of boys, of books, anything. So you need to understand the concept, and this concept we are going to apply again and again in several questions. Alright? Alright. Moving on to the next one, it's question number 3. Find the number of different 4-digit numbers that can be formed using digits 3, 5, 7 and 8 without repetition. So the first part is quite simple, that it's 4 factorial, which leads to 24. That is your part A answer. But if you talk about part B, it says how many of these 4-digit numbers are even. Now the question gets complicated here, right? And why it is complicated? Because now we need to meet the certain condition that the number must be always even. Alright, so firstly I'm going to write down the numbers we have. It's 3, 5, 7 and 8. If it says the number has to be even, that means if we have 4-digit number 1, 2, 3 and 4, on my last number it must be 8 only. And why is it so? Because now we are heading towards even number. For even number, the last digit should be even, and the even number we have is only 8. The last number is 8, and the arrangement of these three numbers, they can vary. It can be 3, 5, 7, it can be 3, 7, 5, it can be 5, 3, 7, it can be 5, 7, 3, any three numbers. So the three numbers are free, there is no restriction, so we are going to say that it's 3 factorial, which is equals to 6. That is your answer, because the last place has already been occupied by one number, because we need to make the certain condition that the 4-digit number must be a even. And for even condition, the last digit should be even. That is why the last place has been occupied, and the rest three numbers are free. They can be appear as any order. There is no restriction. That is why we use 3 factorial. Alright. Now with the same concept, can you attempt part 2 here? So first give it a try. You have a time of 2 minutes or start. Alright. It says greater than 8,000. Firstly, I need to plot the numbers 1, 2, 3, 4. If the number is greater than 8,000, the first number, it must be equals to 8, right? Because if the number is 8, then it is greater than 8,000. Either it can be 8537, 8735, 83757, any three numbers, right? So now it will be 8 in the first position, and the three numbers are free. So it's 3 factorial, and the answer of the second part is 6 as well. So there are two answers, and the concept you must understand. If it says the number must be even, that means we need to work on the last digit. And if it says the number should be greater than any certain number, so we need to work on the first digit. Alright, I hope that it is clear to you. Alright, now moving towards the next question. It's question number 4, and now it is a more advanced level question as compared to the rest 3. It says a shelf holds 7 different books. 4 of the books are cookery books and 3 of the books are history books. Find the number of ways the books can be arranged if there are no restrictions. The word no restrictions means that there is no specific order defined. You can place 3 books of the cookery and then 4 books of the history. You can place 1 book cookery, 3 books history, 1 book cookery, 3 books history. So any order you can pick, there is no restriction. Alright, so you need to attempt the first and the second part. I know that you will take time in your second part, but you need to give it a try. And for these 2 parts, I'm giving the time of 4 minutes, so give it a try, start. Alright, for the first part, you know that if there is no restriction, so we have 7 total books, so it will be 7 factorial. Alright, and the answer for 7 factorial, it's 5040. That is your first part answer. For second part, now there is a condition. Find the number of ways the books can be arranged if the 4 cookery books are kept together. Alright, now listen better. We have total 7 spots, 1, 2, 3, 4, 5, 6, 7, right? And the condition there says that 4 cookery books need to be placed together. So what I'm going to do, I'm going to place a box here, and I'm saying that these 4 books are always kept together. Alright, so the places we have, it's 1, 2, 3, 4. Alright, so now first thing, these 3 books, these 3 history books, they can be arranged in any order. So it's 3 factorial. After that, in that box there are 4 cookery books, and these books can be arranged in any order as well, because the condition is they need to be placed together. So that is 4 factorial for these 4 cookery books. Alright, so answer is 3 factorial into 4 factorial. The last digit is about the placement. This red box, it can be placed at position 3, at position 2, at position 4, at position 1. So there are 4 places, right? So you need to multiply by 4 as well. When you multiply all those 3 numbers, you will get 576, and that is your answer. Alright, so after this question, I think it's quite good if we are going to attempt some of the examples. So it's example from your new book. It says you have a word gradient, as you can see on your screen. find the number of different arrangements of these 9 cards if there are no restrictions. Find the number of arrangements that begin with GRAD. Find the number of different arrangements that begin with G and end with S. So there are 3 different questions, and now you need to attempt all those questions first by yourself. So first give it a try. You have a time of 5 minutes to attempt all those questions, and then I will explain you. So start. Alright. For the first one, you know that if there are no restrictions, so you can easily call the factorial function, right? So if you have total 9 cards, so for the first answer is 9 factorial. Alright, and the 9 factorial numeric value is 9 factorial. It's 362880. 362880. That is your first part answer. After that, for part B, to explain it better, what I will do, I will identify the places 4, 5, 6, 7, 8, 9. It says find the number of different arrangements that begin with GRAD. GRAD. Now, it means that if the number of arrangements that begin with GRAD, it means these 4 places have been finalized now, right? So the rest 5 places, they need to be filled up with any of the leftover cards. So how many places left here? It's 5 places, right? So we can say that for these 5 places we have 5 factorial, and the answer for 5 factorial, it's 120. So there are 120 ways to arrange the letters if you have GRAD as the beginning of every word here. Alright. And for part C, it says find the number of different arrangements that begin with G and end with S. Alright. So G, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the condition is the first word is always a G and the last word with always a S. So among those 9 letters, 2 letters have been occupied. So what about the 7 letters? There is no restriction, so we can say that it's 7 factorial, right? And the 7 factorial answer is 5040. So there are 5040 arrangements if the first letter is G and the last letter is S. Alright, so I hope that you got the idea very well. Make sure that you need to understand the question carefully, and if it specifies any condition, so that method to draw the places, that will be very, I find it very easy to explain and understand. And whenever you are going to attempt a question from permutation and combination, I recommend or I advise you to use those places in this dash form, right? So it will be very easy to you to understand the question, and with this practice there are less chances if you are going to make any mistake here. Alright class, so I think that it is quite enough for today class, and as a homework we have done all the questions from 1, 2, 3, 4, right? So you need to practice all those questions. Give it a try for question number 5 as your homework. Homework question number 5. Alright, give it a try. There are several parts in this, and each part have different condition. So if you can do this question correctly, so that will be very good for you, right? So I hope that you can do it and this concept is clear to you. So see you.